So by now you know that there's a lot of things that go into rendering a frame on Android, and when frame rate starts to suffer, top priority is figuring out which thing has gone off the rails. My name is Colt McCandless, and in order to help you track down where your frame problems are coming from, the M release of Android has updated its GPU profiling tool. Now if you recall, back in Season 1 of Android Performance Patterns, we talked about the Profile GPU tool along with the 3 phases of rendering pipeline that it measured, recording a display list, submitting it to the GPU, and waiting for the GPU to finish its work. But let's face it, things are a little bit more complex than that, which is why in the M release of Android, this tool has been expanded to show you 8 different sections of your rendering frame, conveniently and uniquely colored for easy identification. Now you're already familiar with the first 3 phases here as update, execute, and process. We talked about those before. They still report the same information, so we're pretty much good to go here. More interesting are some of the new stages that haven't been reported before. Firstly is sync and upload. This value generally measures the time it takes to upload bitmap information to the GPU. A large graph segment here means that your app is spending a lot of time doing that, like if you suddenly grabbed 50 new thumbnails or you're uploading an 8 megapixel image. Shrinking this bar usually means things like reducing the number of visible images or reducing and resizing large images before uploading them to the GPU. Of course, then there's layout and measure phase, which report exactly what you'd expect. The amount of time spent per frame executing on layout and on measure callbacks in your view hierarchy. High values here indicate that you have a super complex view hierarchy and thus performing lots of measure and layout phases across a bunch of views. Or you might be the victim of things like double taxation in the wrong spot in your view hierarchy. And shrinking this bar means doing stuff we've already talked about, like reducing view hierarchy complexity and using view objects that can reduce the chances of double taxation. Next is the animation phase, which just shows how long it took to evaluate all the animators that were running that frame, the most common of which being things like object animator, view property animator, and transitions. If this number is high, like above 2 milliseconds or so, check to see if your app uses any custom animators or if some unintended work is happening as a result of your properties being updated. I mean, you'd hate to end up in a situation where updating a property causes a pause due to disk I/O every frame or something like that. And then, of course, there's input handling. This basically measures how long the application spent handling input events, or perhaps more accurately, how long the application spent executing your code inside an input event callback. If this number is high, this indicates that the app is spending a long time processing the user's input, meaning that you might want to offload or optimize that work to a different thread. And finally, there's misc time and vsync delay. If you've ever seen the logs from Choreographer about like missed vsync by blah blah blah, skipping blah 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 frames, that's this thing. Basically, it's the stuff that might be occurring on the UI thread between 2 consecutive frames of rendering. If this value is high, chances are you've got some callbacks, intents, or other work happening that might be ideal to push off to another thread. But with all these colors crammed together on the screen, it's a little tough to make out which ones are causing the problem. That's why if a frame spikes above the 16 millisecond threshold, you'll notice that its bar is drawn more opaque and it's wider than the bars around it. This will hopefully make it a little easier on your eyes to pick out. See, as the platform evolves and developers get more skilled, it's only natural that the tools will evolve alongside it, which is why you should check out the rest of the Android Performance Patterns content, so you can stay up to date with the latest performance tools. And don't forget to join the Google+ community to get advice from other great engineers. So keep calm, profile your code, and always remember, perf matters.